Well, thanks for the introduction. I'm really glad to be here in Dubai at HITB. I have been to HITB before, but not as a speaker. So this is the first time I'm here speaking, present the talk. So what I'm going to talk about is about AI security. Specifically, I'm going to talk about how you can lift some of the AI models from other applications and use by yourself without doing some training. So this is a joint work with some of the students I collaborate with, Deyue and Jiayu and Yufei. So in the past, I have been working mostly in the area of CTF and binary analysis. It's only recent year I started to look at AI and the potential problem with AI security. The host introduced me that I'm still holding the professorship position at the University of Georgia, but I'm on leave. I'm taking a whole year leave working in the industry right now. Let me go to the topic first. So when we say AI today, really like AI for me, like it's referring a really large scope of topic. So initially, when I prepared my talk, I said I'm going to talk about reverse engineering, deep learning applications. Unfortunately, like now the concept of AI, especially in the popular media, like it really mostly recently refer to deep learning applications. So I'm putting a few deep learning applications here. And so when I talk about AI model or AI application today, it's going to mostly relate to the deep learning application. And for the other type of AI, like using symbolic reasoning or the knowledge system, that's not going to be my work's not going to apply there. Okay, so the example I put here, of course, like the popular one, like face recognition and the self-driving, and also I put another example here is like you have all this image processing application. Now take a picture, you train them with some artist picture, then you can convert picture to a certain artist style, and that's going to be one example I use to show that I can lift some of the model and apply it to other applications. Before I go into talk about AI model security, I want to spend a little time talking about AI application security in general. When I say AI application security, I'm talking about if you have an AI application, what kind of security threat you have. And the reason I'm doing this is I put a sort of like taxonomy there is because when we talk about AI security, people often mention lots of different things. Specifically in the academia today, if you say AI security, lots of them really refer to adversary machine learning, like how to train a picture and blur it so that the classifier make mistake. But in AI application, if you look at it as a real system, it really potentially can have lots of threats. The potential attack really can come from different angles. So I put in a few category here, mostly including model security, implementation security, data integrity security, and I'm going to show a few prior work we did on the different type that is not adversary machine learning. Okay, so one of the prior work I did is in the implementation security. This is how I initially migrate from a binary security person to an AI security person. So in 2017 and 2018, we did some work that, first I did a talk in the AI Village and also published a work at the IEEE SNP Deep Learning Security Workshop. And basically, we find a bunch of security vulnerability in the deep learning framework, in the implementation. So I'm going to give you a really quick overview about what we did there. So the target application there, in order to demo the problem with the deep learning application, is that we use the native example come from the Cafe. Like Cafe, if you use the framework, if you download the framework, there's a sample application allow you to classify, pictures. You give a picture, you run their examples, they will tell you what is the output, like what's in the picture. For example, in this cute cat picture, they will say there's a certain type of cat in it, what is the confidence level. Okay, and what we did is we create a couple of pictures. This is again not adversarial machine learning. I'm not messing up the machine learning algorithm. We are only messing up the pictures metadata to try to explore some of the vulnerability in the implementation. And this 4 picture on the top left corner, that's the original picture, and the other 3 are the one we put in some bad stuff in there. So the result of this, again, we ran the same program, the model and the data now trained by us, and this is the result. And I showed this in the DEF CON AI Village. So the 4 result is the original ones. Clearly, it says it's a bulldog. Again, I don't expect you to read the small font. Okay, I'm going to use picture to indicate what's the classification output. The other one is shows there's flying pig. Basically, we can create an output because we can. I basically we put code there, we hijack control flow there, so we can say anything, right? And we can certainly make the program crash, and then we can also own the system. I'm going to come back to this later, when we talk about a cloud-based model. So that's one work I quickly review. Okay. Another piece of work we did right after this implementation security one is we again look at the AI application, consider it as this whole system, rather than just the algorithm. Then I did a presentation in last year on the DEF CON China, the first DEF CON outside the United States. So what we did is, again, I create 4 pictures. One is from the original one, then the other 3 are different. What we are targeting against using this picture is that we're targeting the data processing, pre-processing stage. So when we have a AI application, like deep learning application, typically people assume the input is in a certain size. But when you're making an application like a cloud service to do image classification, you have to deal with all kinds of pictures. Not all the pictures are created by cameras. You can have, human to, intentionally put some bad stuff in it, or you can have different size. So usually there's a pre-processing stage in this, and I highlight in the right font. There's a scaling part, and some of my students even when I first present this, they say, okay, they write their own application that they never use a pre-processing. They can handle all kinds of size of image. Well, it turns out that some of this resizing pre-processing is buried in the deep learning framework. So I'm highlighting one here. And again, it's hard for you to read the small text of code. This is the function I copied from the TensorFlow, the framework. The function name is called read tensor from image file. And inside I highlight one line. That's what does the resizing for it. It turns out we can leverage some problem in this scaling of pre-processing. So this is the effect that we create. We can, create picture that looks, to human, has some meaning, but when it resizes, it has completely different meaning. And also, recently we also tried a different cloud image classification service. And this is the output we put into an online classification, well-known service. I'm not going to name the vendor. We report to the vendor already. And clearly, for the ship image, the vendor says it's a wolf. Okay. So now let's go back to our main topic. So early on, all I did there is try to tell you that when you have an AI application, there are really lots of potential, place you can attack. I gave you a flash of that big taxonomy. There's really lots of potential factors. And one thing I love about AI and the AI researcher is that it's because these people are mostly from the image processing and audio recognition background. They really have a naive thinking about the threat factors. So there's really lots of things you can poke. But now let's come back to the AI model security. So first, let's look at what is AI models, right? Again, by AI here, I mean deep learning, okay? So I put 3 pictures here. This is really like popular example people put up. The very first one is called Amnist. It's a digital image recognition application. And usually when you talk about this application, you see that picture in the middle. Really, it's like a layered network. The middle one is the ImageNet one, the cafe example that take the image, recognize what's in it. Same thing. There's the middle one. There's the layers, right? And the last one is it's the Dave 2 self-driving example, open source released by NVIDIA. Again, and there's a layer example. So take the first one as an example. Often you will see this type of picture, but have you ever looked at what does the model file look like? Okay, I'm going to let you see some of the simple one, right? So look at this very simple one. This is the Amnist one. And if you take the example, this is usually come from the framework. Doesn't matter, TensorFlow, Cafe, Torch. They usually gave you this example. Okay, and there's multiple files. The important one you should look at is 2 files related to the model. One is really the model file. In this case, is the .cafe model file. A .proto text file that describes the layer. Really, what it is, it's hard for you to read the text, so I'm going to give you an enlarged version. Okay, so this basically tells you each layer, what's the input size, what's the scale, and what's the layer before and after, how they link together. Okay, so it's very simple for you to understand. It's, the layer file usually is defined using the Google Protobuf format, and it's easy to read. But when you train a model, like when you get lots of data, you run through your training, usually there's a more important file. Not only the topology is important, when you have data, train it, what you get eventually is a parameter file. So this is the second file I get from the Amnist dataset. This is the Lynette Cafe model file. This file I got again from the Berkeley site, and what this file contains is the parameters in all the layers, the topology there. And usually this is because this file is large, so usually it's in the binary format, but we can convert to text. So what is contained in that file, I just show you a part of it. It really shows you on each layer what are the parameters there. Now, the number of parameters depend on the size of the layer, the scale, and for the complex one, the complex model, like for example, the face, the Facebook one, the one doing the image, the face recognition one, and I think there's a few 100 million parameters there. So that's what's stored in this. These are the output of the training process. When people spend effort to train it, what they generated is this. Okay, the layer, how the model look like is what's shown on the picture. It's really what's in the previous file. Okay, now hopefully you got a rough idea about what is AI model, and let's look at the potential problem with this. So remember, I put in this big taxonomy, slides. Again, that's really my view about this, and I hope that makes sense for you. On top of it, it says model security, the top group. Okay, and the very top is adversarial machine learning. Again, that's not our interest. Our interest today is model theft. Okay, what does model theft mean? In fact, in academia, there are actually lots of study on this already in terms of how you can steal something from the model. So I'm going to go into a little bit about the current academia study, and then I'm going to come to the reality to show you that in practice, there are much worse problems there and much easier for the attacker to do something. So in the academia, people are thinking the following problem. Okay, so assuming that someone, like some company spent lots of effort, trained with some data, then you come up with an AI model, So let's say in this example, you put it on the cloud, and you allow user to send query to it. Like for example, you can have user send the image there. They will tell you whether there's cat in it or maybe something more interesting there. Now, we all realize, at least the academia part, realize that this AI model and all this parameter is really valuable. That's a core part of the core asset of the AI application. And in fact, one thing the founder of NVIDIA says, the new source code is data. It's, today, like the model has become the valuable assets. Now, what all these academia research have already done is they try to see, can we steal this? Like basically by querying the model many times, and can we construct our model that's pretty much the same as the previous one, as one in the cloud? So there's a URL put up there, there's a paper, and the GitHub, the project name called StealML. So what they did is that they consider that if there's a model there, you can query them, and they consider there's the input and an output function, and they try to see if they can infer through some correlation, and in one extreme case, consider this, like if I don't have a model, but I have a lot of pictures, let's say I have a million or 10 million image, I can send a query to this service, like say if Facebook offered the service or Microsoft or Google, I send query and then I got label. Basically these service become my label, generator. Then I have the label, then I can run the training, by myself, right? That's one extreme case. Well, these paper, the people in academia already published papers saying, if you are using some simple machine learning model like the SVM or the decision tree, some of the parameters can be inferred. That's what the academia research have been done before. There's also effort related to this, like some of the threat, like called model inversion attack. It's not only they're going to learn the model, they also want to learn some of the thing in the data. Say like, are you using certain data? Are there any data being used? So that's called model inversion attack. And the well-known example is this work published a couple of years ago. So what they did is that they made a relatively simple, like they have their neural networks like only 3 layers, or really like only one hidden layer, and they have a small set of data, image data. They train it, then they can use early on what I mentioned, the type of attack, try to infer what's in the data. So on this slice, on the leftmost picture, that's the original picture used in the training, and then through their attack, then they can infer the picture. This is this is a picture they infer that potentially in the training data. So that's the academia research been done before, and so far they show success for traditional type of machine learning, algorithm like SVM, decision tree, or for really simple setup. I don't think, personally, I don't believe you can easily do this on a large, like cloud-based model through this approach. I don't think that's really realistic. But there are lots of other, academia research work, recently about like informed membership and other. I'm not going to that, much detail. What I want to tell you is that actually the academia researcher, like I was in that community, right? They are usually like to look at lots of hard problem, okay? But in practice, the problem was actually different, okay? First, I will let you, tell you different. So let's look at the reality. It's really like some company build an AI, application, and they have their own valuable data. They train, they spend lots of time. They really need to pay attention to other type of risk. So I put it first, reverse engineering attack. So we decided to look into this, so we start to look at some of the apps. So these are the list of apps. We look at it. They are mostly for image and video and audio recognition and special effect type of applications. And they use different type of artificial intelligence, the deep learning frameworks. So I put the information there. One interesting thing, first we noticed this. I'm not going to name the application because we tried to talk to the vendor, but we couldn't reach them. And this is also not necessarily a problem. So one interesting thing we noticed first is that In their configuration, like when you open the application, and this is an application that gave you like the artist effect, right? You take a picture of a cat, you can transform to like Van Gogh style, or maybe Picasso style of a cat. But when we look at the configuration, and there's a button there, and I enlarge it so hopefully you can read it. What it said is that if online processing, this option is turned off, images are processed using a computing power of your device only. Okay, what does that mean? It means that you don't need to talk to a cloud to use the AI service, and that indicates that there's local AI models on the in the APK or on your on your device. So we start to look at it, say, where are these AI models? Where are the parameters? Where are they stored? Where are they stored? Can we lift it out from the application? It turns out this is not hard first, okay? So I put this into a few categories, okay? Most of the applications have locally stored model. I will explain why we have so many of these. Okay, the very simple one, and some of them are really easy for you to take away, and they just like, they have a directory, have the model there, and including all the original one. But this is not the most common one. Lots of them actually try to hide it, but they are using the dumbest way to hide it. You don't even need to open IDA to find it. Like they just name it in a different way. Like some of them, I'm not going to name the application. It's in that picture. They just call like .mp3. Like they were hoping you never open that file, right? But then lots of them using encryption, but because all this has to be done locally on the phone, so they usually like decrypt it, and in their code. So AES and RSA is really popular, but they also, hard coded their key there. I will show you one example. And some of them like even go a little bit further. They hide their key, and their stack node being used. They hide their key in a picture, but again, everything is there. Okay, and then there's also a group of applications that they use the hardware-specific type of model. So then even you lift it, either you have to translate it back to a common type of model format, or you have to use specific hardware. And then there are also a group of applications that initially in the APK that doesn't have this. And when you start use certain feature, they will download the model to your phone. Okay, but again, when they download the model and use it on your phone, you can still use it. Okay, so here's a few examples. So on the left side, I put two APK in their directories, and both of them actually have the model on their assets directory. But again, there are some of them put into even other directories like resource and buried deeper, but lots of them put it in the assets. The right side of the picture I showed is the case that some of the models are downloaded at runtime. When you only use that feature, they will download and they put it into a different location. Some of them put it on the flash card. Some of them put it on their temp file directory. Now, the question you might have is like, why they are doing all this? Why not just put it on the cloud, right? Because this is a valuable asset. Why they are doing this? It turns out that if you pay attention on the latest development on the mobile, the handset part, the new trend there, it turns out all the smartphone, the vendor, they are trying to put in AI processing ability on the phone. Okay, I put 3 pictures there. On top there is the Huawei, their 970. This is not the latest. I think they also have a newer model, and they're claiming that on their mobile handset, they have 1 or maybe 2 chip dedicated to do the neural network, the deep learning processing. Okay. So then in order to use that capability, you have to put in the model there. And the same thing happened to Qualcomm and Samsung. And the factor they claim that why we want an AI model running locally on the phone is because a couple of things. One thing they mentioned is you don't want to have the data use the bandwidth. Like if you have the image processing and the especially video and it takes too much bandwidth. So they don't want you to send all the data there. Sometimes they say too much delay. Also, they argue about the privacy. It turns out like it's a strange thing. Like, I guess they are trading their own like data privacy. They're giving all the data then so that they claim that users don't want to sometimes upload the data to the raw data to the cloud. So they do the local AI processing. Okay. So as a result, if you ever developed like a AI application, the developing process actually changes. So again, I'm ignoring all the other, logic and application, dependent process. The training process usually like, when you use the framework, usually like you have some data, you label them, you train them, then you get this model file. In the old concept that you simply put up this, AI model, either, locally if you want, and more likely you're putting this up on the cloud. And then in your APK, you have like an API, you query the cloud, and you get the answer. That's the, initial way people think about how to build an AI or, AI-enabled or deep learning-enabled application. But it turns out with all this newly developed the hardware-supported AI processing capability, the new developing process changes. When the developer finish and have the model ready, they don't deploy this directly in the application or in the cloud. What happens is that either Qualcomm, Huawei, or Samsung, they provide this SDK, let you run this and convert your model to a hardware-specific model. Okay, in the Qualcomm case, we look at it, they convert to this thing called DLC. In Huawei, they have this high AI case. Okay, so that's why we have so many of the AI model actually sitting in the application. Now, let's go back to see if, we do some reverse engineering and what do we find. And the very first example to prove that lots of people are doing this hard-coded case, and we just, again, the label there, like for example, this particular application actually the symbol has been stripped, and the name is actually put back by us. And you can see that they are actually load this, and they have a hard-coded key, and then they have they use AES to decrypt it before you use it. So it's a simple script. You can once you have the key, you can extract the model, and this is how the model look like once you decrypt it. Okay, now. The question now is like, if you think about from a reverse engineering point of view, it's really like how to locate the model files. Once locate the model file, then it's become your traditional like reverse engineering effort. So a few clue actually left out to do the to reverse AI model and make the reverse engineering actually easier compared to the reverse engineering of other data format. So usually these are the local stored file, at least for the application we look at it. They usually load the file at the either the init stage or their Java code and call the create handler part, and then you can usually follow find the model there, or if you didn't find anything there, you can try to follow all the fopen calls and try to see whether they are doing anything. And often there are actually lots of other framework based information make your life easier to recognize where are the model and how they use model, because you need to locate the code to know that they are already start to use the model, so the model loaded is before all these functions. So lots of these framework has very specific term and names, and they're using really specific function like like cafe, and also when they start to classify it, they almost always use the forward. So you have all this framework provide all these clues for you, and giving you an extreme case. This is an example. They didn't even strip the symbol. So you go there, you notice that they are using cafe, and you can easily locate where are the functions. So this is a quite easy case. Some of the other applications actually try, certainly at least did some effort try to hide it, okay? And so they're trying to first strip out the symbols so you don't, easily find where are the functions and where are the deep learning related function. But then if you ever, look into the implementation or a little bit detail about the deep learning the framework implementation, you know that they are actually heavily doing lots of matrix, multiplication, transformation, and there are also used lots of mathematical function like not commonly used, at least in the field of my knowledge. So, for example, the exp function is all being used a lot in the polling and in the different layer in the deep learning, but they're not really common in the typical in the typical application logic. So if you just locate some of this key mathematical function and you can traverse back, they can easily locate where are the framework functions, and then you have a good chance to know like where the model being loaded. Okay, so basically for all the applications we look at up to this stage, by using all I just mentioned, we can locate pretty much all the model file. But we also did a little bit further work to try to say, in case people try to start to hide all this deep learning framework functions. So first, I think lots of people didn't do that is because the framework is quite big, and if you try to hide all those, it's probably easier to find it. And also we noticed that all these deep learning framework functions, lots of them present really strong, dynamic fingerprint. So we did some experiment. Again, we didn't even apply this. The following two slides, the technique we did is really, from our experiments. We didn't even need to use this in all the application we look at it. So what we did is some experiment. We take sample applications and we try to look at the behavior at the runtime. So we are doing some of we measure the memory access offset, and we plot it over time. And these are some of the over time we see some of the memory access pattern. And it turns out that it's very easy to locate, pinpoint this back to some of the deep learning, layer, the typical layer function that, they very often, present really strong clue in terms of memory access pattern. And we also even look at the case that if you choose different parameter for each of the layer, and it turns out that if you look at the memory access pattern, you can also reflect that it tells you something about the deep learning framework. It tells you, like for example, in this case, if the convolution layer, what is the kernel size, what is stride. So they really have really strong memory footprint. So if you want to hide this, you probably need to try lots of effort to obfuscate it, then probably mix it with other memory access pattern. So we feel like this is probably difficult for the obfuscator to do this work. So the next thing I want to show you is that I'm going to show you, even let's say if you lift this file, you locate the file, you decrypt it, you successfully recover the deep learning application's model and the parameter. What are the steps you need to do to use it? Okay, so this is again is from a popular image processing application. This is the one that take an image and you can have different artifact. Okay, and in this particular application, they have lots of built-in models, and they also have download models. Like if you select it, then they might pull it online. Then they also have two versions of this application. One is like if your phone is not has a AI chip, is not have a hardware deep learning processing capability, they have one version. There's also a version that if you have an AI capability, they have a different version. And in the version with the AI capability, the model is not even encrypted. So you can just copy the file and you can use it in the environment. For the one that, targeted for the phone without the AI capability, then they are actually using AES and with the stack node hiding the key. And that, we also get that reversed. So to use this, first, you need to load this model. Like, so what we did is we take a dummy sample application. This is from the Huawei High AI model. This application doesn't do anything, okay? It loads some really dummy model, but it's nowhere close to the sophisticated artist model that we lifted. But so first we need to get that load into the application. And in this example, we're using the one has the hardware specific ability. Is really the one, the model file we lifted is called 2.Cambricon. And then we just, all we need to do first is make sure we load this right model. And we are using this model manager from the Huawei case. And the second step, once you loaded the model, in order to get the image to use this model, you need to know what the input layer, the initial input layer, and what the output layer look like. So you still have to reverse this, model, look into the model format a little, in a little bit more detail. So in this picture, I show that in the hardware specific model where you can find the initial layer, the input information. In fact, we completely reverse engineered the specific hardware format, hardware model format. And this is the screenshot of when we open the file with our own 010 template. And you can see that what the initial layer, look like. And once you have all this information, you need to also modify your application so that you need to get the image, to the right input size in the input scale. So what we did is to take the high AI application, which already had the input and output size there, and we just modify it to the right size there. Okay, and every time you need to specify the image, the input and output size, you have to modify that correspondingly. And the effect, here's the effect we got. Basically, we get the picture, we have, initially this is simply showing the picture, the application is simply showing the picture, and now we can let it show the artist effect that we borrow the model from another application. And the important thing to mention is that in this case, we didn't do any training. Okay, we don't have any of the artist, the sample data we use that the company actually spent effort there. And so we can basically just copy their model and use it here. Again, this is simply just for a demo, okay? We're not using this, on any of our product, but I'm trying to use this example to show that once you have the model ready there, others can just simply leverage it without, really train this. Now, that's the simple case for the either the model now well protected or using some simple obfuscation you lifted. But now let's talk about some of the new protection being added. When I mentioned that there's a new process bring up by the hardware vendor, like including Qualcomm and Huawei, when they bring this SDK, so they also, I'm not going to name the vendor. One of the vendor also bring a protection mechanism I'm going to mention next. But in order to use a model, let's say you lift a model from, let's say, for example, a Qualcomm phone, and using Qualcomm's SLC model, you can either use the model directly on a similar type of phone, or you have to translate it back. So what we did is that we actually write a software tool to allow you to convert the Qualcomm, the local Qualcomm specific model back to a generic, cafe model. So the slide, what shows here is that on the top of the slide shows that this is what the command line that Qualcomm provides you. Like once you have cafe model, you can use that command to convert to like local model. But then the bottom line shows that we can actually turn it back. Now this is we only did this for Qualcomm one, and we can convert it completely back because in the Qualcomm case, it doesn't lose any precisions in the data conversion. Some other vendor, again, I'm not going to name it, they lose precision. So like if when you have the original model has a double data representation, it might convert to an integer, then you convert back, you lose some of the provision. So we didn't do that, but potentially you can do something like this. Let's talk about the protection. So one of the vendors actually did this. When they take the model, like already trained by some developer, you have this Caffe or TensorFlow model. When they convert it to the vendor specific hardware model, they add an encryption there. So if you simply lift the model out from the application directly, you will notice some part, it's actually, you cannot really read the content directly. You have to, decrypt it. And the decryption right now, the location they did is still on the handset, but it's not in the APK, it's on their server. There's a service. So they have a specific driver to handle the AI hardware, and they decrypt it there. Okay. Now, there's two things happening in this case, and we already talked to the vendor. Unfortunately, I cannot tell you the detail, but one thing I can tell you is that this protection put up is so weak. And the previous slides I called it encryption. It's not even a really real encryption. Okay, so I put a quotation encryption there. So you could easily reverse it. Okay, so again, because the vendor didn't give us permissions, I cannot tell you the detail. But if you figure out, you can figure it out by yourself. It doesn't take much time. But one thing I do want to say is that they could make it stronger if they not only make the encryption, certainly make a real one. Let's say if they use RSA, do it. And if they do the decryption in the hardware, that will make this AI model much, much safer. And that's one of the recommendations we provide to them. And I think hopefully they take this approach. So in the future they might have a platform that they only take encrypted model, and they when they do the work in the hardware, they do decryption there. Then that will make the decryption difficult. Okay, but certainly you still have the issue of the model. Only the application only have the protection on that particular model phone. If you don't use a particular vendor, if you use a different vendor, then you still have to deal with this. Okay. Now, certainly, with all this said, you probably, I'll think back to say, okay, at least if you are building an AI application, you should think again to say, do I put a local AI model, or maybe I should put it on the cloud? So let's look at the cloud case. What if, we are using a cloud-based AI service? And in the past, again, I told you there are lots of academia researchers doing this, but so far I don't think you need to worry about that directly. People are talking about inference, about data, from the cloud. I think that's still, it only works for the really simple case. It's still hard to, apply to really complex model. But you should really go back, look at the software vulnerability. So at the end, I'm going to show you what we did before, and that have implication on the AI model security on the cloud. So this is work I present a year ago at POC, so 2017, and it's about implementation security. And so this is a case we use, we demonstrate that even you have a cloud API and you put your, all the work in the cloud, it's still, there's still threat because of your implementation security. So the demo we did is that we have a application on the phone. It's called Cat in the Picture. So what it does is it sends a query to a server on the cloud, and the cloud runs the Caffe model and all the service, and the cloud only responds to query. And the attack we use is actually based on a bug we find. This is again, this is reporting in the POC 2017, and it's a heap overflow, and basically it's in the image header processing stage. I'm not going to go into the detail of this because this bug has been explained before by us. Now, but I do want to go through the process briefly to tell you the threat. So again, what happened is for this application, it can take picture sent to the cloud from the camera, or can take from the photos that in the album folder. So what it does is it takes the picture, send to the cloud to do the query. And what the cloud runs is really the native cafe examples. Like if you download the cafe, and if you have the cafe image classification, and we actually use a Google trained ImageNet model to do the work. And what the server does is it's just send back the prediction result and with some of the confidence in information. What happened is that if we leverage the bug, we send in a special cropped picture, and this picture sent to the query, then they will spawn a reverse shell and connect to the attacker prepared machine. Okay, so then we will have a cloud access to the machine. Then we can really just copy all the model. The server is running on the server is completely installed and untouched by us, and we didn't modify any of the software. These are original software, and it's all either from Berkeley or from the Google model. And I have all the information about the commit and the original software version and setup there. But again, this is 2017 information, so hopefully they already fixed this. So this is pretty much all I want to tell you. So overall, I showed you that potentially for AI application, there are different types of threats. The topic of today's presentation mostly focused on the model theft part, and that's related to the model security. But I think I also mentioned, I spent lots of effort, also talked to you that there are other aspects of the AI application security, including the implementation security and the data integrity security. So to summarize this, in a few sentences, first I want to really emphasize that the data, the model, and the parameters are really valuable assets in the AI application. Lots of companies spend lots of effort to train it, but if you don't pay attention, you don't protect it, if you put it as part of your application, you might just give out to others. Okay, and right now there's a really a trend for lots of applications actually go to use the local AI model. This is driven by the hardware vendors. So this has become really popular. So you should expect to see more of the application using local models. But because of deep learning frameworks, it's really complex, and most of the application are not really building their own deep learning framework, so they are actually using the existing one. So end up they are using this in their application, and these frameworks really provide really strong clue for the reverse engineers. And at the end, I also want to emphasize that if you have software vulnerability buried in your supply chain, either in your supporting library or in the deep learning framework, that potentially also can compromise your application, even you put the models in the cloud side. So that's all I have for today, and I think I still have time to take questions. Thank you. So, any questions? Oh, sorry.
I wanted to ask, what about training in encrypted domain? So there have been work done in that side. Would such type of vulnerabilities still exist in the encrypted domain?
So I don't exactly understand the meaning of a training in the encrypted domain, but so the model we were looking at, or the scenario we're looking at, is that someone's building a service, right? It's you have either a AI model on the cloud or AI model in the local machine, and you're sending data there and you're getting result back. And the magic is really that AI model there. So if even you are using I know there are work on training in the encrypted domain, and I don't know there are any practical implementation, but if you can abstract the problem in the case of an API from a user send data and some magic happen, the result come back. If that magic is being represented as a model and that model being lifted, I think the threat is there. But again, I'm not sure I understand the scenario completely.
Thank you so much. Thank you so much.
Okay.
Do we have additional questions? Going once, go. Oh, there we go.
Okay.
Okay, maybe you gave us some hints on this, but you mentioned about hiding the parameters by encrypting. Would it make any sense to try to hide the model itself, not the parameters, or maybe both of them? Maybe either programmatically or by leveraging encryption as well. So trying to make it more difficult to reverse engineer the model itself and not only the parameters.
Right. So I think people are trying to hide, both the model parameter, try to hide it deeper in the application. But the trouble right now, like compared to the other application, in the other situation, I think deep learning application, AI application is more difficult for them to hide because they are using a particular framework. And that framework, in order to use it, you have to first load the model, then you call forward. So there's a fixed routine you have to follow. And that routine basically exposes you. Unless you say, I'm not going to use TensorFlow, I'm not going to use Caffe, I'm going to use my own special one. And some of the application framework, we look at it, try to go that way, but they modify Caffe a little bit. But because you're heavily relying on all this, it's hard for you to hide. That's the sort of thing I try to deliver.
Yes, thank you very much.
Hi. So currently there are antivirus software out there that uses deep machine learning techniques to detect malicious binaries. So do you think these categories of threats that you highlighted earlier applies for them as well?
The short answer is yes, but as far as I know, for the antivirus solution that use deep learning, most of them, as far as I know, actually using a cloud service. So they do some not deep learning, like traditional type of machine learning, type of work in local, but then they usually go through a cloud. They send their sample to the cloud, and then they get the answer back. So their model are not likely on your phone, but we haven't looked at it because there are really not many antivirus application on the phone. We only look at the Android APK. With that said, certainly, the two type of threats I mentioned today still applies. I think if they have models on the phone, probably you can borrow. Second, if their service on the cloud, potentially, I think it's worth for someone to poke to test whether there's vulnerability there on the cloud by just sending some bad samples there. I think there's a good threat vector there.
Thank you.
Any more? Nope.
And there's another one. Did you consider a Tempest attack on the mobile phone?
Can you repeat the
A
question?
Tempest attack, so an emanation, electromagnetic emanation, kind of side channel.
You mean side channel attack to try to steal the parameter?
Yeah.
We didn't even look at too sophisticated effort because for the application we look at it, I showed you a few examples. It's pretty obvious where the data is. And I think, when people first, like AI applications are relatively new and people are rushing to just, get on the market. So they didn't realize that, they are leaking important, assets there. I think there's going to be a trend now, like probably more people are going to start to protect those. So then if we couldn't get the model or the infer the parameter using the traditional way, then we might have to go through other approach. But so far, not yet.
So this is all the time we have for Q&A. So thank all of you here for your outstanding questions, and let's please thank the speaker once again.
Thank you.